Welcome to the pilot action of the new Metro project. The new Metro project aims to identify and support skilled workers in Industry 4.0, with an emphasis on training needs and emerging skills across Europe. As part of the project, the Laboratory of Knowledge and Intelligent Computing of the Department of Informatics and Telecommunications of the University of Ioannina, as a partner of the project, created a series of videos for security. In the beginning, we will refer to the cryptographic tools for protection of authenticity and confidentiality. The section includes communication protocols for secure Internet transactions, key sharing protocols for the Internet, SSL, TLS, PGP, SSH, IPsec. First, we will refer to the communication protocols for secure Internet transactions. What is the HTTP, HTTPS we see on a web page? These are data movement protocols between networks. The HTTP, Hypertext Transfer Protocol, is used to send information between two systems, between a web server and a home computer. It is a secure hypertext transfer protocol with the addition of the S, secure. It can also transfer information between systems, but more securely. Chrome has blocked websites that use HTTP. But, what were the first steps in communication protocols? Initially, the Internet was not widespread. Therefore, there were no security and privacy issues. In 1965, HTTP was created for communication between two parties. It seemed enough for the time being. It took 3 decades to revise the protocol. Why did we have to revise the protocol communication? In 1994, the HTTPS protocol was created. Why? Let's look at the Internet today. We make daily transactions such as banking transactions, online shopping, emails. Information had to be secure, and HTTPS was the only way. How does it work? Through the SSL, Secure Socket Layer, protocol created for this purpose. It then evolved through TLS, Secure Layer Security. The protocols are installed in the browsers, Chrome, Firefox, etc. Technically, the protocols encrypt the websites and prevent malicious actions when we visit them. Next, we will refer to the key sharing protocols on the Internet. Key sharing protocols on the Internet are used to create a Security Association SA to the IPsec protocol. The AH and ESP protocols form the IP packets based on cryptographic algorithms and corresponding keys, agreed based on the protocol of key sharing. All keys and algorithms constitute the security correlation. The key sharing protocol for Internet access uses 2 protocols, ISAC, OCLI. With the establishment of ICATI, 2 security correlations are created. One inbound and one outbound. Each correlation offers different keys for the ICATI, Internet Key Exchange Protocol. Conclusion. Through ICATI, a secure channel between 2 parties is created. Certification and exchange of keys between them is required. A common key for encrypting the ICATI channel is agreed to via the Diffie-Hellman protocol. When the certification and key exchange process is concluded, an IPSA is created and secure communication is now possible. Moving on, we will present the cryptographic tools SSL, TLS, Secure Sockets Layer. SSL, Secure Sockets Layer, was created in 1994 by Netscape. This is a security protocol. It provides encryption, authentication, and digital signature mechanisms. It ensures confidentiality, integrity, and authenticity in the communication between two parties. Thus, it creates a secure communication channel between a user and a server. The SSL structure consists of 4 protocols. Running at the network level, SSL Record Protocol. And at the application level, SSL Handshake Protocol, SSL Change Cipher Spec Protocol, and SSL Alert Protocol. It is implemented above the transport layer and it ensures the secure transfer of data to the HTTPS protocol. The TLS, Transport Layer Security Cryptographic Tool, was created in 1999 as an evolution of SSL. It uses a hash function for message authentication, HMAC. SSL uses Simple Message Authentication, MAC. Specifically for the implementation, we distinguish 2 phases: handshaking phase, data transfer phase. In the handshake phase, the user and the server agree on a set of cryptographic algorithms and exchanging cryptographic keys for the certification of identity. This includes 4 steps. The user sends a greeting message, client hello, to the server. It includes the highest version of SSL that can be supported, the supported cryptographic contexts, cipher suite, the supported compression methods, and a random number. The server also sends a greeting message in return, server hello. It includes the SSL version, a user-suggested encryption environment, a compression method suggested by the user, a random number, and finally, its public key. In addition, it sends a completion message, server hello done, that it has sent the previous messages and the handshake phase is concluded. The server sends an authentication certificate to certify its identity. The user sends a 48-bit client key exchange. The key is generated by him and is encrypted by his server's public key. It is used to generate the master key. The user sends a message that he is ready to start the secure communication, change cipher spec, and the message that completes the communication, finished. The server sends the same message to the client. Once the handshake phase is over, the data transfer phase can start via the SSL Record Protocol. The protocol breaks the data stream into smaller pieces and sends them to the recipient, encrypted. The recipient can decrypt the data. We continue with the PGP cryptographic tool. Created in 2004. Ensures data confidentiality, the authenticity of the communicating members. Combines the speed of classical encryption, the encryption of the public key in the transmission of data. At first, an encryption key, which is unique and valid for a single session key, is created. With its help, the encrypted text is generated. The session key is encrypted with the recipient's public key. It is sent along with the ciphertext to the receiver. Decryption is realized inversely. The recipient, who has acquired the PGP copy, will use its private key to obtain the session key. Another cryptographic tool is SSH. Created in 1995. Initially SSH-1, with several problems. Then SSH-2. Network Protocol. It provides encrypted connections between 2 parties. It is used for secure remote connection and execution of commands with other devices. It also offers secure network services, such as file transfer and web browsing. The properties of this tool are: data protection using strong encryption, data integrity, Authentication of the members of a communication. Authorization to access services. Promotion or tunneling for TCP/IP session encryption. Data protection using strong encryption. Data integrity. Authentication of members of a communication. Authorization to access services. Promotion or tunneling for TCP/IP session encryption. The SSH tool uses public and private key encryption and hash functions. Keys are divided into symmetric or secret keys and asymmetric or public keys. Their size is from 1 to 2000 bits. Here are 4 basic key types. User key. This is a temporary asymmetric key, used by the user to declare his identity. Session key. Symmetric key, used by both parties of the communication for the purpose of encrypting it. Both parties obtain it during the connection process. Host key. Asymmetric key, to indicate the identity of the server and the device running the SSH server. Server key. It is used in the SSH/1 version and protects communication of client and server in SSH/1 protocol. A secure channel is created. This contributes to the exchange of passwords and data. Steps. The client calls the server. Both sides reveal the SSH protocol they are using. The server is disclosed to the client. The client sends a secret session key. Encryption is performed on both sides and the certification of the server is completed. The secure channel goes into operation. The SSH/2 protocol is composed of 3 distinct protocols. Transport Layer Protocol provides server authenticity, confidentiality and integrity of data. Runs above the level TCP/IP. User Authentication Protocols. It runs over the Transport Layer Protocol. It offers authentication for the client of the server. Connection Protocol. It runs over the user's transport layer. Finally, we will refer to the IPsec cryptographic tool, Internet Protocol Security. Internet Protocol Security. Created for high-quality security in versions IPv4 and IPv6. Provides authenticity, confidentiality, and integrity to secure communications on an IP network. Uses security protocols with cryptographic algorithms and cryptographic keys. Protects communications between 2 parties. 2 security gateways, router firewall. Both mechanisms and parts of a communication, computer firewall. 2 protocols to ensure data movement. Authentication, header, AH. Provides authenticity and integrity of data. Protects against replay attacks. It also protects headers. Safe content integration, encapsulating security payload ESP. Provides authenticity, confidentiality, and data integrity. It does not protect the header of the IP packet, unless the encapsulation mode is used. 2 protocols to ensure data traffic. Protocols can be used in combination or separately. Each protocol supports 2 modes. In the transfer mode, the IP load, and not the IP headers, is encrypted. The encryption starts before TCP and after IP heading. In tunnel mode, the entire data frame, IP datagram, is encrypted or authenticated to an external frame that has its own header. In general, IPsec offers flexibility to the user. Which communication method does the user want? Which operation, mode, transport, tunnel? Which cryptographic algorithms? And how can all these be connected? This is where our presentation about the section Cybersecurity General ends. For more educational material about this section, you can visit the e-learning platform we have created. as part of the new metro project. Thank you very much.